Okay, fifth graders. Little homework help. There were a couple students absent today, so I'm just going to start from the beginning here. We'll go through this here pretty quick. So look at this page here. It says you've got 135.8 feet of material, and you need pieces that are 16 feet long. And it says about how many, so it doesn't have to be exact. Solve this problem any way you choose. So, you know, there's more than one way to solve this. And 135.8, we could say that's about 140. 16 is, well, you could say it's close to 20. You could say it's close to 15, but 20 will go in 140 a little bit easier. In fact, it would go in 7 times. So 7, I think, would be the correct answer. But when we're talking about estimating, there's a little bit of leeway there. So I know many of us, and I think maybe in the other videos we did in class, we had 16 as 15. So not worried about the bottom part of the page here. You can put a line through that. Let's look at page 234. I'm not going to go over this so much, and the bottom part I'm not worried about, but they just give you a problem here, and they show you a couple different ways to solve it. Number sense, Leo is estimating, and again, we did these in class here, and estimating doesn't have to be exact. So it would make more sense at first glance. 53 is a whole lot. 53.1 is closer to 53 than it is 54. And 8.4 is closer to 8 than it is 9. But if we think of it in terms of compatible numbers, actually 54 divided by 9 would make more sense because it goes in evenly. Okay? And you can explain that. Put that in your own words. Number 2 here, it says, is each quotient greater or less than 1? How do you know? And so let me do this problem here. There's a couple rules and conditions when we divide numbers with decimals. And so we're going to divide, it's 0.2 being divided by 4. Okay? Whenever you have a decimal, you just take it, you just bring it straight up. So this is where the decimal goes. Does 4 go into 2? It does not, so put down a 0. So then what do I have to do here to this 2? Well, I have to add a 0. So now what is this? This is 20. Does 4 go into 20? It does. How many times does it go in? It goes in 5 times. And there's nothing left over. Okay? Subtract 20 from 20. So the answer to number, or letter 2A here is 0.05. 0.05. Okay? Just remember, when you have a decimal inside here, you just bring it straight up. Now, let's look at the one just below it. Okay? So this is 1.35 being divided by 0.6. So there's a couple rules here I want you to pay attention to. Whenever you have a decimal on the outside, you can't divide with it. So you need to move it over. And whatever you do on the outside, you do on the inside. So what do we have to do with this decimal? We have to move it over 1. So I can rewrite this problem as 6 going into 13.5. See, notice how I moved that decimal over? And this one here is right here. But I won't put it there because we all know that whole numbers have the decimals just to the right. So does 6 go into 13? Yeah, it goes in twice. It's 12. What's left over? 1. What do? We bring down the 5. Does 6 go into 15? It does. How many times? Twice again. But don't forget, decimals go straight up from where they are. And I'll put down that 2 now. This is 12. Okay, what's left over? 3 left over. Now what? Well, add a 0, Okay. Does 6 go into 30? It does. How many times? Goes in 5 times. So the answer to B is 2.25. Now, let's see here. 2.25. So I did this one for you guys, and you guys can try to squeeze your work in or put it on a separate sheet of paper. And so you would put, is each quotient greater or less than 1? So this one is less, and this one is greater than 1. All right? So in 3 through 8, we're estimating, and so in class we came up with some numbers to work with. And let me see here. Okay. So we call this 42 divided by 7. Change the 6.8 to 7. Called this 100 being divided by 10. That's pretty easy. 5 was 50 being divided by 4. Okay. This would have been 70 divided by 7. Down here would be, I think we called it 15 being divided by 2. And if somebody puts 16 divided by 2, well then what would the answer be? It would be 8. So that's fine. If you do use 15, it'd be a 0.5 left over. Or not 0.5 left over, but the answer would have a 0.5 in it. Let's see here. This we could just call 40 being divided by 6. That would make sense. I'm not worried about 9 and 10 here. Put a line through those. And let's see here. Number 11. So let's see, 7 divided by, just call that 1. 12 would be 10 divided by 1 again. 13, and we'll just call that 18 being divided by 3. That would go in evenly. How about 90 being divided by what? What do you think? It'd be 5. And this would be 45 being divided by 5. We call this 800 being divided by, how about 80? Makes it pretty easy. And then this would be 21 being divided by 3. How about 15 being divided by 10? And the last one, how about 150 being divided by 15? Let's look at this 15 being divided by 10. Let's put 15 right there, and let's put a 10 right here. 10 goes into 15 once. What's left over? 5. Okay? So the decimal goes straight up. And then how many times? Oh, now we have to add a 0. 10 goes into 55 times. So the answer is 1.5 for number 18 there. Okay? All right, next page. A couple of those I wasn't worried about you guys doing. So let's see here. Number 20 is Lucy's mother gave her $7.50 to buy 8 spiral notebooks with tax. The cost of each notebook is $1.05. Does she have enough money to buy 8? Can she buy 8? Well, we did this in class. There was more than one way to do this. Quite a number of students just simply decided to multiply 1.05 or $1.05 times 8. And that gave them an answer, and they compared that with 750 to see if she had enough. That was one way to do it. Let's see here. Number 21, a few of you asked me about that. It says, Carrie said that the quotient 4.2 divided by 4 is about 8/10. Because 4.2 divided by 5 is close to 40/10 divided by 5. Do you agree with her reasoning? Well, so let's do this here. 4.2, whoops. Should be a 0.2, not a 0.5. Getting ahead of myself here. 4.2 being divided by 5. Does 5 go into 4? It does not. The decimal goes straight up. Does 5 go into 42? It does. How many times? So 5 times 5 is 25, plus 1 more is 30, plus 2 more is 7. So 5 times 7, 35, 8, so 40, 8 times. 2 left over. Okay, bring down to 0. Does 5 go into 20? It does, 4 times. So 8.4. Well, 8.4 is really close to 40/10. All right, so do you agree with her reasoning? Yes. And you can put that in your own words because 8.4, or 0.84 rather, is close to 40/10. 22. My book's here so I can get this in the proper place. Not worried about it. 23. Let's see here. Lisa's car averages 14.5 miles per gallon, while Roman's car averages 28.5. Well, we could just call this, how about 15 miles per gallon? We can call this, what, 30? Use estimation to find out how many times as many miles per gallon Roman's car gets compared to Lisa's car. Wow, that was really worded oddly. They want you to compare. So a couple students asked me about this one. So let me ask you a question. If I gave Lisa 1 gallon of gas, how far could she get? She'd get 15 miles. If I gave Roman 1 gallon of gas, how far would he get? He'd get 30 miles. He'd get twice as far. So you can put that in your own words, that basically Roman's car gets 2 miles for Lisa's every 1 mile. Or you could say that Roman's car travels twice as far as Lisa's on 1 gallon of gas. Okay? 24. So which sample from the experiment has the least mass? Well, here's the mass. All right, now remember, what's this 9? Where is this 9 in the place when we're talking about to the right of the decimal? That's the tenths. What's the 8 right here? That's the hundredths. All right, so keep that in mind as you look at these, because here's a 0 in the tenths place and a 0 in the tenths place. So, and which one has the lowest temperature? Here's the temperatures. I'm going to let you answer those on your own. Somebody asked me about this one, 25. Sample 3 was used in another experiment. This is the sample they're talking about, sample 3. It says a temperature of 82.14 centigrade was recorded. How many degrees did the temperature change? Well, what was the temperature in the original sample 3? It's right here. So you're going to compare this one with this one. That's what they're asking you to do. And how much did it change? In other words, what was the difference between the two? Okay? 26, what is the difference in mass between sample 1 and sample 2? Well, they're talking about sample 1 and sample 2, and they're talking about mass. What's the difference between the two? Difference is what? Subtraction. Okay? All right, 27, 28 you can do on your own. I think I did one of those with the class, but I think you guys can figure that out. Okay, that's it. Short video. Hopefully it helps. And I will see you guys tomorrow.